Okay, so now we are recording. And we are gonna do this today. So we are gonna discuss the discrete probability distributions today. Okay? All right. But before we do that, we do have to go over some stuff. There was this question in your homework quiz that I think some people had trouble on. So we're going to discuss that for a minute, okay? So let's see, what does the question say? The question is that we have a bag with 4 green balls and 3 red balls, okay? And they're well mixed. We draw a ball from that bag at random and we do not put it back. So what does that mean? With replacement or without replacement? We do not put it back.
Without replacement.
Without replacement, perfect. So, and then we draw a second ball, okay? Now we have to find the probability that at least one of those 2 balls are green, okay? That's fine. Now, first, let's clarify some language. What does it mean when they say at least one of those 2 balls? What does the word in general, in English, what does the word at least mean?
Only one ball has to be green.
At least one ball has to be green.
One or more?
Yes, perfect. Thank you. Yeah, I saw the chat too. Thanks, guys. Yes, 1 or more. Okay, so when we draw the first ball, that can be green. Also, when we draw the second ball, that can also be green, and then both can also be green. That's what we need to find. Okay, is the question clear?
Yeah.
Mm-hmm.
Okay, now how do you go about it? Any ideas? Don't give me the answer.
I have an idea.
Yes, go ahead.
You can pull out like green, 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 red, red, green, and red, red, and then come up with those possibilities. Can you do that?
Okay, yeah, that might work, but let's go for some nicer approach, some easier approach. So let's think about it. Tricky one, but smart.
You can try to find the probability that you don't pick a green ball.
Perfect. That's good. Why is that good? So let's see why is that good. So we do have 4 green balls and we have 3 red balls. So in total, we do have 7 balls. Now, if we're drawing 2 balls without replacement, and we need to find the probability that at least 2 of them are green. So what is our A? What is our event A? Our event A is that at least one of those 2 balls need to be green, right? Either one ball is green or both the balls are green, right? And that can happen on first draw or second draw or both draws. Does that make sense?
Yes.
Yeah. Okay. So now, tell me something. If we have A, event A, what should be the complement of event A?
The what?
Complement of A. So you know how if we have a space, we have A and we can have A complement, and those two events would make up my whole space. Yes, yes, I'm reading the answers in the chat and they're all correct. Yes. So let's see. So A complement will be neither of the 2 balls is green. So both of them can be red. So that's my A complement. So that's the event that I had A, I have now its complement. And we know that if we have event A and we have event A complement, they both, the union of those 2 would form the whole space. Now we know that the whole space, the probability of the whole space should be what? 1. Perfect. Thank you. Yes. So the probability of the whole space should be 1, and the probability cannot exceed 1, right? So we know that the probability is 1. So if we have probability of one of either A or A complement, we can find the other one easily, right? Because probability of the space is just sum of probability of A complement and probability of A. Does that make sense?
Yeah.
Okay, perfect. So now let's find the probability of A complement. So which is neither of the 2 balls is green. So that means on both the draws, I need to get red balls, and then I am drawing without replacement. So I have total 7 balls and I have 3 red balls. So what is the probability of getting a red ball on the first draw? Anyone? Yes, 3/7. Perfect. So 3/7. Now, how many balls do I have left in total?
4,
Six.
6.
Yes. And then how many red balls do I have left? 2.
Two.
Yes. Thanks, chat people. 2. So the other probability should be what? To pick out the second red ball. Over 6. Perfect. Good job. So if you look, that is the probability of a complement. That is the probability of neither of the 2 balls is green or both of them are red. So now, am I done? Is that
No.
what I wanted to find?
No.
No. Good job. No. We wanted to find the probability of A, which is just 1 minus the probability of a complement. So 1 minus 1/7, which is 6/7.
Oh, I got this shit wrong.
Make sense?
Yes.
Any questions?
Yeah, no, I forgot to do the 1 minus.
Yeah. Okay. But it makes sense now?
Sort of.
Well, we have to break the question and then work on it. So I hope it makes sense now. Did I move forward?
Yeah.
All right. So let's recall some. That was just in general homework question or homework quiz question that some of you had trouble on. So we just went over that. Now, what is today's lecture about or today's discussion about? It's about random variables, and as you have probably heard about it in lecture 8, so we have 2 kinds of random variables. One are discrete random variables, and the other one is continuous random variables. Does anyone know what's the difference between these terms, discrete and continuous?
The discrete, like the distinct, something like that, and the continuous, like it can change.
Sort of, yeah, you're on the right track. So discrete is, so for, let's say at some point x equals to 1, I have a discrete number corresponding to it in the y. So if I plot that, I will probably get a dot, like, because it only exists at that point. So let's say at x equals to 1, I have some probability. At x equals to 2, I have some probability. At x equals to 3, I have some probability. These are discrete. But if I say I have probability between 0 and 1, 0 and like 1 and 2, like all that continuous range, then it's continuous.
Hmm.
Between some range, because then it exists between those dots. The probability exists between those points. Okay. Right. So there are 2 kind of probabilities we will discuss based on the what kind of variable do we have. So for discrete random variables, we have probability mass function and cumulative distribution function. And for continuous random variables, we have probability density function and cumulative density function. Okay. So in any case, the cumulative one is called CDF, but please don't confuse them. One is cumulative distribution function and the other one is cumulative density function. Okay, that's just some vocabulary. Right. Right. So now we are gonna discuss how to go from one probability to the other, and today we are only gonna discuss about the discrete case. Okay. So remember this problem in worksheet 1, where we were given these specific points. How do we, like, now we are going to discuss the same thing, but in terms of probability, in terms of PMF, and then we'll also consider them as CDF. Okay. So we have here some probabilities given up around those discrete points, right? So the first part is to sketch the graph, and then we have to find the probabilities of these others. Okay. So let's see, how would we sketch? So remember in the worksheet 1, we sketched it as these little dots, right? That is fine too, but let's learn another way, which is this. So since at a equals to 1, our probability is 1/36, So you see, we have a bar here about that. Then we have 3/36 at 2. So we have another bar. Now we have a bar graph. These are all the probabilities we have corresponding to that point. Okay. Does that make
Yeah.
sense? Yeah.
Yeah.
So now let's see. Let's go over this example again. What are the values for P of negative 0.5?
0.
0. Because we don't have that in as a part of our A, and we know that any other point other than these specified A's, our probability is 0. Okay. So what is P of 0?
0.
0. Good. What is P of 2?
3/36.
Good job. P of 3.5?
0.
Good. And probability of 7?
0.
Good job. So that's what that is mentioned right here in this part. Okay. Any questions? Okay. So yeah, you can either draw it like that or like that. Okay. So now what I'm gonna do is put you guys in breakout rooms, and you guys are gonna work on this exercise, and then we'll regroup and discuss about it. Okay. Before we actually do your worksheet. Sounds good?
Yep.
Okay. I'm gonna make some breakout rooms. I'm gonna. All right. So welcome back. So I hope you guys discuss this problem. Now, let's see. Okay. So we are talking here about CDF, so which is very different than PDF, right? Because it's cumulative. So as we know, at A equals to 1, our probability, our PMF was 1/36, right? And then at A equals to 2, we have 3/36. What does cumulative distribution mean? We are accumulating, we are summing it up. So if we see f of 1, the CDF at 1 will be just P of 1 because we don't have anything to go off of from here, right? We don't have anything to go off of from here. But if we look at the next one, f of 2, that will be probability of 2 plus probability of 1. So the probability of 2 itself plus the 1 prior to it. Okay. Similarly, for 3, it should be the first 3. The sum of the first 3. Does that make sense?
Yes, ma'am.
Okay. Thanks for the affirmation. Okay. So what's going on? Let's see the bar graph here. So here, the bar graph looks a little different than what it looked for the PMF, right? If you see, the PMF went barely till here. But for the CDF, it went all the way up to 1. Why? Because if you look, if you add up all these probabilities, they should add up to 1. So that means the last bar for CDF should touch 1, which it is, right? Okay.
Yes.
Yeah.
Make sense?
Yes.
Yeah.
Okay. So that's the holistic picture that's going on. We can't have a probability above 1. We can't have a probability below 0. So the least probability can be a 0. The highest probability can be as 1. Okay. So that's what the picture looks like. Now let's see. Let's see first the the plot for this. So the plot looks like a step function. Now, how does it work? So we know that from 0 to 1, we just have 1/36 for CDF, right? That's just probability of 1. So from 0 to 1, wherever there's a point between 0 to 1, if someone asks us what's the probability, or sorry, CDF between 0 to 1, that is just 1/36. Okay. But for between 1/2, it changes, right? Now between 1/2, it's the sum of these two. Then between 2 and 3, it is the sum of these 3. Similarly, 4, 5, and so on. So here. And I see that touches 1. Okay. Now let's get a step further and see this one. What is the probability, or what is the CDF of 3.5? In other words, what we mean is probability of this variable less than equal to 3.5. That means probability of 3 plus probability of 2 plus probability 1 should be the CDF for 3.5. Let's pause. Let that sink in. Make sense? Any questions? No? Okay, cool, thanks. All right. So now we know about discrete random variables, and now we'll split up into groups again and do the worksheets, and then we'll go from there, okay? I'm gonna stop recording.